Nevertheless, over some period, this was reinterpreted and given the contemporary naturalistic approach, namely, aspects of the world can be studied at various levels and they have whatever property they have. So if in fact I can affect the moon by moving my arm, sounds crazy, but if that's the way it turns out, okay. Intuition is irrelevant. Furthermore, there are many levels at which we can study this reality, whatever it is. We're going to try to integrate them. That's the sensible version of the unification problem. There is no notion of existence or reality apart from what figures in our best explanatory theories. In particular, there is no theory at all of the physical or the material. Therefore, we have no coherent question to ask about what lies outside the physical. There no longer is a mind-body problem, except just by arbitrary stipulation. And the reason is there is no such thing as body. Till somebody tells us what physical means, there's no question about what lies beyond the physical, and physics has no concept of physical. It's just whatever we come to understand, or maybe more narrowly, whatever we come to understand in such a way that there's at least a reasonable prospect of integrating it with the core natural sciences. Kind of loose idea, but there's no concept of physical or physical reality beyond that. Turning to the case of thinking or solving problems or speaking a language, right now we are, in this sense of physical reality, we're most confident about the physical reality of computational representational systems, at least by naturalistic criteria. So let's take an actual case. There are recent studies in the case of language, interesting studies, of within the study of computational representational systems, you find many different categories of expressions. I won't give details, but for example, there's a category of well-formed expressions, perfectly grammatical, and then various kinds of deviant expressions, and they fall into all sorts of different types. That's internal to the study of computational representational systems. Only very recently, there's been some work on electrical activity of the brain, or called event-related potentials, in which people have, pretty surprisingly but interestingly, discovered specific correlates to these categories. So a particular kind of category of deviant expression yields a characteristic event-related potential, the specific kind of electrical activity in the brain. Well, that's kind of interesting, but why is it interesting? Well, it's interesting because notice that the thing we're committed to from a scientific point of view is the categories of expressions given by the computational representational system. Those are the categories that come out of a background of theoretical explanation. The event-related potentials are just curiosity. I mean, what's interesting about them is that they correlate with what we understand to some extent, and therefore maybe they're interesting. Notice these are two studies of the brain at two different levels. One, it's electrical activity. One, it's computational activity. In the case of the computational activity, we have reasonably well-grounded theories with explanatory character and so on. In the case of the electrical activity, we know nothing, just a lot of noise up there. But now the study of the electrical activity of the brain has made progress because it has found something that correlates with what we understand much better, namely the computational representational systems. Now, maybe if these correlations are extended and placed in a richer theoretical framework, we'll actually begin to rely on them for some inquiry that'll tell us something about the computational representational systems, but that's the order of priority and groundedness from the point of view of the natural sciences. The usual I stress that because the usual interpretation, again, is the opposite, and mistakenly. Of course, in this naturalistic approach, we would never ask such utterly pointless questions as whether airplanes fly, or whether computers think, or whether algorithms see triangles, or whatever. Now, what are the real empirical questions and the reasonable research programs? Well, I think they're the ones sketched earlier. It seems to me if we want to learn something about humans or pigeons or whatever, we should begin by considering something that they do well, and we should try to figure out how they do what they do well. We postulate some particular faculty of the mind, meaning the brain at a relevant level of abstraction,